Number 8 says a jar has 8 mints and 10 pieces of gum. If you randomly take 3 pieces, what's the probability of grabbing 1 mint and 2 sticks of gum? So one bag here, we're saying one container, it's got 8 mints and then 10 pieces of gum. So if you kind of think about, maybe we'll just kind of draw something here. So we'll say 8. So let's say you got 1, 2, 3, 4, 5, 6, 7, 8. So we got 8 mints, and then let's say we've got 10 pieces of gum. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then what we're saying is what's the probability that you'd get 1 mint and then you'd get 2 sticks of gum? Now, it doesn't really, I don't care which mint. I don't care if it's that mint or that mint or that mint or that piece of gum or that. So this is an example where it's a combination. The order doesn't matter. It doesn't matter when I reach in there and grab a handful. It doesn't matter what, and again, I'm actually, and let's clarify there. There's only one time I'm reaching into this bag. So I'm not reaching in once and then again and then again. I'm reaching in one time and I'm grabbing a handful. So when I pick up that handful out of the bag, again, it doesn't matter which, I just want 1 mint. So it doesn't matter which one of these 8 mints that it is, and I want 2 sticks of gum, so it doesn't matter which 2 they are. So it doesn't, again, this is a combination, the order doesn't matter. I just want this outcome right there. I want to grab 1 mint, and I want to grab 2 sticks of gum. Right. Well, so I've got two things going on here. I've got the mints, so I've got to figure out what's the probability that I'll get a mint. So let's say I got to figure out my probability that I'm going to get a mint, and then I got to figure out my probability that I'm going to get gum. And again, it's 1 handful. Well, in terms of mint, I'm going to choose from 8 mints, right? Because I've got 8 mints. I want to choose 1. And then from gum, I've got 10 pieces of gum. So I'm going to choose from 10, I want to choose 3. And then this is a total, because then if I said, well, because again, probability is what you want out of the total that's there. Well, this is what I want. I want 1 of the 8 mints, and I want 2. Oh, I'm sorry, I wrote 3. It's not 3. I want 2 of the 10 pieces of gum that are in there, right? So 8 mints, I want 1. 10 pieces of gum, I want 2. Now the total, what I'm trying to do is out of a total of how many things are in the bag. Well, there's a total of 18 things in the bag here. So from a total of 18 items, I want 1, 2, 3. So this represents the total. So because a probability is always what you want out of the total that's there. How this problem is different than let's say what we looked at earlier with what would that have been? I guess number 5, guys and girls. This wasn't saying what's the probability that we'd get 3 guys and 2 girls. This is saying how many different ways can we arrange this group of people. So there's no fraction here. It's only when we talk about probabilities that there's a fraction. Now, so as far as kind of simplifying this out, so let's take, maybe we'll just kind of scroll down, or I'll scroll down the page here a little bit. So I've got some random G, whatever that is. So I've got 8 factorial, so let's say for the mints. So I've got 8 factorial out of what I want, which is 1 factorial, out of what I don't want, which would be 7, right? Because I don't want all 7 mints, I just want 1 of them. And then times, for the gum, I've got 10 sticks of gum, don't want all 10, just want 2, so that means there's 8 that I'm not picking. And then for my total, I've got a total of 18 things, and then I want 3 of those things in the bag, so there's 15 things in the bag that I don't want. So this would be a situation where we could use just the calculator to kind of simplify things for us instead of writing all of that out. So I'm going to take the first one. Let's say the mint. So we'll say 8 factorial divided by 1 factorial, 7 factorial. Oop, hit the wrong thing there. 8 factorial. And you can see we're on this particular calculator. The TI-84 is great for a lot of different things. In this particular case, it's kind of a pain because the factorial key is actually not kind of on this main screen. Kind of have to go into a little sub-menu here. But like I said, on your own scientific calculator, if you're using a scientific calculator or one on your phone, there should be a key for it. So you notice that it's 8. Oh, well, that actually should make sense because if we just want one of the 8, right? Since we're just picking one of the 8, so that's where we get 8. And then for the gum, so we've got 10 factorial. So math PRB divided by, and again we're using parentheses here so the calculator doesn't confuse order of operations. I always use parentheses when in doubt because sometimes the calculator gets it right and sometimes it doesn't. So we get 45. And then for my total, so I've got a total of 18 pieces of candy in the bag, but again I don't want all 18. I just want 3 of them. So if there's 3 that I want, that means that there's going to be 15 that I don't want. And I'm going to close that off. And so we get 816. So it's going to be kind of a weird looking fraction here, because if I say 8 times 45, right, if I multiply the top of the fraction, I get 360. And we could reduce this fraction down, but to be honest with you, we want to be able to speak of that in terms of a percent. Like what's the, is it a 15% chance this is going to happen, a 20% chance? So what I'm going to do is I'm going to take that 360 and I'm going to divide it. So I'm going to say 360 divided by 816. And I get 0.44. So we'll round that. We'll say it's approximately a 44% chance. So we're saying there's approximately a 44% chance that if I reach into this bag and I just randomly grab 3 things, that there's a 44% chance that I would grab 1 mint and then 2 sticks of gum. Right? We're also making the assumption that we can't feel the difference between a mint and a stick of gum. Obviously, in real life, a stick of gum would feel different than a little mint. But we're making the assumption that we wouldn't be able to know the difference, or that maybe if we just kind of randomly dumped out 3 things, that it would be that. All right, so that concludes number 8. So try the one on the right, and then we're going to finish up with the last problem.